Let's have a look at the same table. And the question is, do you believe in aliens? It's an interesting question. Here is a survey of 100 college students asking that very question. Do you believe in aliens? So you see, the columns indicate one category and the rows indicate one category. The first thing is to identify these two things. So in this table, the columns indicate their choice, yes and no, and the rows indicate the gender. Rows indicate the gender. That is why it's called a two-way table or a contingency table. And these are some of the questions that can be asked. The first question is, how many males were asked? So we are looking at this row. How many males were asked? 10 said yes and 32 said no. So the total number of males are 10 plus 32, that is 42. That's the answer to this question. 42 males were asked. The second question is, how many college students believe in aliens? So you can also rephrase the question like this: how many of the students said yes? So now we are looking at this column. So 48 students said yes. That's the answer to this question. We are not asked whether how many students were male or how many students were female. That's not the question. We are simply asked that how many students in total believe in aliens, and that's 48. Let's have a look at this table. A recent survey of 100 college students asked if they prefer to drink tea, coffee or an energy drink during finals week. Here is the table created from that survey. Again, it's a two-way table. The rows basically indicate the gender and the columns indicate their choice. How many college students drink tea given that they are a female? Now we've got two conditions. So what I do is basically I highlight the row or the column that's asked in the question. How many college students drink tea? So we are basically looking at this column. Given that they're female, so 18 of the students drink tea and are female. That's our answer. Very simple. Let's have a look at the second question. Let me use a different color for that. How many students drink tea or are male? This is an interesting question. Students tend to make one silly mistake over here. Please don't do that. Let me tell you what that is. How many students drink tea or are males? So this is the column that we are looking at, or are male. We have another scenario over here. We are looking at this row as well. So let me do that. So this is basically our total answer that we are looking at. So we are looking at this column and this row. But you need to understand that there's one overlapping region, that's this green one. You can't add this twice because it is coming in this column and in this row as well. So that's what you need to subtract from your answer. So the total tea drinkers are 20. Total tea drinkers are 20 and total males are, you add. So whenever you have an or, you add. Remember the probability? We talked about this. So total males are, we have got 2 plus 15 plus 39. These are the total number of males. But you need to understand that you need to subtract this 2 from this entire equation because you cannot add this twice. This will be our answer. Please remember this thing. So we have 20 tea drinkers plus we have got 56 males minus this 2, that is the repetition. So our answer is basically 74. This is our answer to this question. So 74 students are tea drinkers or are male. Now let's have a look at the third question. I have erased the working because it was getting really messy. Let's have a look at this question. How many coffee or tea drinkers are not female? How many coffee or tea drinkers? So what do? You close this region first. So we are basically looking at this region, tea or coffee drinkers. This is our table. This is our box that we are looking at. So let's look at each part. Let's highlight the coffee and tea columns. We have already done that. Now let's highlight the male row. Why male row? Because the question asks for drinkers that are not female. So if they are not female, they have to be male. Very simple. So male drinkers, males who drink tea are 2 and males who drink coffee are 15. That's our answer. So 2 plus 15 equals 17. There are 17 males that drink coffee or tea. Next question. Several English professors categorize the literary works from their seminars by time period and length as shown in the table above. Okay, so this is the time period. So the rows basically indicate the time period and the columns indicate the length. We have length over here and we have time period here. So we've got fewer than 100 pages, 100 to 499 pages, 500 or more pages, and then total. Okay. According to the table, what percentage of those books with 500 or more pages? With 500 or more pages, let me log this. So this is the column we are looking at. Are from the 19th century. Are from the 19th century. Now we are looking at this row. So what's the overlapping region that we have? We have this number 6, but we need the percentage. Now here's the tricky part. This is where students tend to make mistakes. Which total should I take? 12 or 14? The question will tell you. Please read the question again. What percentage of those books with 500 or more pages? I need to take this total with 500 or more pages, not this 14. Because this total contains 100 to 499 pages as well. This number contains fewer than 100 pages as well. That's not the total we are looking at. We are looking at this total. Please remember. So it should be 6 over 12 into 100%. The answer is basically 1 by 2. It is 50%. So just be careful with the total that you're taking. That's why I highlight the rows and the columns. It will help you a lot. Next question. Michael asked the 10th and 11th graders at his school which sport they preferred between basketball and football. Okay, so we have got football, basketball here, we've got 10th graders, 11th graders here. Okay, and this is the total column that we have. The table above displays a portion of the results. If 20% of the surveyed students who prefer football are in 10th grade, so 20% who prefer football are in 10th grade. So this number basically represents 20%. Let me write it here. 20% represents 30 because this is important. Then how many of the surveyed 11th superscript graders at Michael's school prefer basketball? 11th graders and basketball. This is our target answer. This is what we are looking at. So this number is a huge hint. So if 20% represent 30, then we can easily calculate this total. Let's say this is basically 100%. So 100% represents what? X. Do the cross multiplication, see what do we get. We have 20x equals 30 into 100. Please do not multiply. Remember the strategy. It will cancel out. We have 30 into 100 divided by 20. This 0 cancels out with this. 10 divided by 2 is 5. 5 into 3 is 15. We have got 150. So this total is 150. Now you know that 30 plus this number equals 150. So you can easily calculate this number as well. So 150 minus 30 will give us this number. That is 120. So 30 plus 120 equals 150. Now we have a total row here as well. So that means this number plus this number equals this number. This number plus this number equals this number. Similarly, this number plus this number equals this number. So 120, I can write it like this. 120 plus Rx, let's say, plus X equals 166. X equals 166 minus 120, which is 46. That's our answer. And that is option choice B. Next question. A science textbook has 4 chapters, each with a number of skill problems and of analysis problems. Okay, we've got skills problems and analysis problems. Let's look at the table. We've got chapters over here, we've got skills problem here and analysis problems here, and this is the total, and this is the total as well. Okay, a table representing this information is shown. Based on the table, which of the following statements is true? Okay, interesting. The relative frequency of analysis problems coming from chapter 4 is 4 by 39. Chapter 4 is this and analysis problems is this 4 and the total number of analysis problems are 39. I was about to highlight this, but analysis problem was huge, so I was like, it will get messy. So yes, we understand it is 4 by 39. This makes perfect sense. But hold on, let's try other options as well. The relative frequency of analysis problems coming from chapter 2. Analysis problems coming from chapter 2. Let me use red color for option choice B. Is this? Chapter 2 is 21 by 89. No, this is completely wrong. We have got 11 questions from chapter 2 on analysis problems. This is definitely wrong. Option choice C. The relative frequency of problems in chapter 1 being skill problems. Chapter 1, let's use green color for this. Chapter 1 being skills problem is 11 over 50. That's the number we are looking at. Is 12 over 23. No, this is completely wrong. Definitely wrong. The last option choice is the relative frequency of problems in chapter 2 being skill problems. Chapter 2 being skill problems is 10. Is 2 by 3. 2 by 3. No, if we look at all the skill problems, then the answer that we will get is 10 over 50, which is basically 1 by 5 and not 2 by 3. This is definitely wrong. And even if you do 10 divided by this total, even then you don't get, this is not equal to 2 by 3. See? So definitely our answer is option choice A. Another interesting question. Victor decides to try 3 different routes to work for a period of 40 days. In the table above, he tracked whether he arrived to work late or on time each time he used a particular route. Late or on time. Okay, so the rows basically indicate the route and the columns indicate the number of times he was on time or late. Okay, according to the table, what is the probability that Victor was late? Okay, this is one condition. Given that he used route A, this is the second condition, very important. So let's do the same exercise that we have been doing earlier. Victor was late. This is the column that we are looking at. But the more important information is he used route A. This gives you the total. Remember, total is very important. The question will tell you which total to use. So our answer is basically 6 over 11 and not 6 over 27. Just be careful with that. So that leaves us with option choice D.